Hello and welcome back. In this lecture I want to talk about some common mistakes that you'll make while programming in C. Some of these you might be familiar with from your previous challenges and you've already actually encountered these errors, but these are the most common types of mistakes. First one is very obvious. It's missing a semicolon. Remember that all statements in C will end in a semicolon. If you don't have it there, the compiler is going to complain. So either misplacing a semicolon or missing a semicolon entirely is a really common error. In this case, we're misplacing a semicolon. We have an if statement, we put a semicolon at the end of the if statement. And this actually causes the behavior of the program to be completely different. This will actually compile. When you miss a semicolon and don't even have it included, it will not compile. But in this case, the value of j is always going to be set to 0 because the semicolon on the if statement was placed. So the semicolon is perfectly valid to have it after the if statement. It actually represents the null statement, and therefore you don't have an error by the compiler, but this will cause a problem because j will never ever be set to 0. And this type of mistake can be common in looping as well. When you have a loop and you put the semicolon at the end of the for loop, and then you may have a bracket, it's gonna, or you don't have the bracket because you'll have an error if you have the bracket. Very common. Another one is confusing the equals operator with the equals operator. Specifically mention that the equals operator is not actually it's not comparing strings. So if you use equals when you're comparing strings, that's not valid. It's just going to compare the references. But if you actually mean to assign a variable to a value to a variable, and instead you use the equals, you're going to have a compile error. Now, if you try to compare two items, like two integers, inside of an if statement, and instead you use the assignment operator, you actually won't have a compiler error, but you're not going to that expression is always going to evaluate to true. So when you use the equals and you don't use the equals, this is usually made in if while do statement inside the Boolean expression. And this is valid, except it has the effect of assigning to something as opposed to executing something. So in this example, if we have if a equals 2, it's assigning 2 to a. It always is set to true because that's a true statement because you never fail when it's doing assignment. And so printf is always going to run. What you really meant to do here is say if a equals 2. So it's very common using the equals as opposed to the equals and then not have a compiler error. If you use the equals in the wrong situation, you may have unexpected behavior as well, but you will have a compiler error if you're using it incorrectly for assignment. But be careful of this with the equals instead of the equals. Omitting prototype declarations. I mentioned that it's really important to always declare your functions at the top of the file before you use them. However, this doesn't always happen, and it's a very common mistake. And usually what will happen is you'll get an implicit declaration error in the compiler. In this example, if you have square root defined later in the program than where you're invoking it, or in another file, and you didn't explicitly declare it, you're going to have some warnings. The compiler is going to assume that the function returns an int. It's always safest to include that prototype declaration at the top for all the functions that you call, either explicitly or implicitly by including the correct header file in your program. But when you don't include those prototype declarations, you can have errors. Failing to include the header file that includes the definition for a C programming library function being used in the program. So in this case, you want to reuse some code. Maybe you have the printf function, you want to display some output, but you do not include the standard lib header file. That's a mistake. And that will be usually told to you by the compiler. There will be an implicit, there will be a linking problem with that function. So in this case, we have double answer equals square root value 1. If this program doesn't include the math.header file, this will generate an error that square root is undefined. It will go try to link the object files. It won't have a math.o, and it will say, hey, you're calling the square root, but there's no implementation for it. So make sure you include the correct headers for all of your invocations of functions, especially from the standard library. Confusing a character constant and a character string. So here, if we have text equals A inside single quotes, that's a single character that's assigned to a text. If we have a variable named text and we assign it in double quotes, that's a pointer to the character string. Right? That is not valid for a single character. And this actually, we talked about string constants and assigning them to character arrays, and how you can't do that with the equals, and you have to actually do them with the stir copy. In this case, when we say text equals A, it's assigning a pointer. And this actually isn't valid either in C. What you would have to do is you'd have to do the star text equals A, or the star copy if you don't want to assign it directly like that. But you get the gist. Using an A inside of single quotes versus a character inside double quotes, completely different. Character versus string. In the first case, text is normally declared to be a char variable, and in the second case, it should be declared to be type pointer to a char. And if you want to assign a value to that pointer, other than the pointer itself, you'd have to dereference it. This is actually incorrect because if it's a pointer, instead of assigning an address, you're assigning it a string, so that doesn't make sense. Using the wrong bounds for an array out of bounds exception. Here we're declaring an integer array of 100 size, and then a couple variables I and sum, with only sum being initialized. And we go through our loop, and we say for I equals 1, I is less than equal to 100. That's incorrect, because the size of 100 means that there's 100 elements in the array. But arrays are zero-based, so the first element is 0. The max index that you can assign or access in the A array is 99. This is going to less than equals. So you're going to have an out-of-bounds mistake here. This is not a valid subscript. All right, because this loop is going to go all the way to 100. It's also probably incorrect because you're starting at 1. If you really wanted the first element of this array, you would start at 0. Forgetting to reserve an extra location in an array for the terminating null character of a string is also a common problem. When declaring your character arrays, they need to be large enough to contain the terminating null character. This is why I would suggest to you, you don't put a size in an array when you create it if you're initializing it. You would only put the size in there if you're not initializing it. If you're creating and initializing on the same line, let C do the work for you. It will automatically put the right size, and it will include that null terminator. So, for example, if you have a character string called hello, this is more than 5 memory locations. It's 6 because of that null terminator at the end. Don't forget about the sizes of your arrays. This is a common problem with pointers, which we haven't discussed a ton about, but I did want to just mention it because it's very common. In pointers, when you want to access, or even in a struct, when you want to access something by a pointer, you have to use the dash greater than symbol. That's used when you're accessing a pointer element. All right, so if you have a pointer that's pointing to a structure, that's how you access it. If you have a structure that's not pointing, it's not a pointer, then you access it using a dot, the dot operator. A lot of times this dot operator and this dash then greater than is used incorrectly. Dot for non-pointers, pointers dash greater than. This will become clear in more of our examples. Omitting the ampersand before non-pointer variables in a scanf call. So remember our scanf call, it expects a pointer as a second argument, and that means an address. When we declare a data type, a variable of type int, that's not a pointer. So in order to allow scanf to store that data in our int variable, we have to pass it the ampersand to say it's an address. So this is incorrect. Not having the ampersand before number in scanf as the second argument is not valid. The only time you do not have the ampersand is if you're using a pointer, like a character array. All arguments appearing after the format string in scanf must be pointers. Using a pointer variable before it's initialized. So here's an example of creating a pointer and then trying to assign to it. And this is the correct assignment where you're assigning a value, you dereference it. But what we haven't done here is we haven't initialized the pointer to actually have any memory allocated for it. And you can't do this in C. You can only apply the indirection operator, which is the asterisk before, to a pointer variable after you have set the variable pointing somewhere. So it has to be pointing somewhere. Right now it's null. It's not pointing anywhere because you didn't allocate any memory. So the chart pointer is never set to point to anything, so the assignment is not meaningful. This would actually cause a segmentation fault. Another common error is omitting the break statement at the end of a case and a switch statement. If break is not included at the end of a case, then execution is continued to the next case. Right, so this is what I mentioned where you have a case, it gets evaluated, and if you don't have that break in there, it goes right to the next case and will execute the code inside that next case. So you always want to have breaks inside your case statements. There are times when you want to have a fall through case to another case and they do the exact same thing. In that case, you wouldn't have anything inside the case statement. Inserting a semicolon at the end of a preprocessor definition. Preprocessor definitions, remember, start with the number, the pound symbol. The preprocessor is run before the compiler, usually for optimization. And so the correct syntax for preprocessor definitions are not to include a semicolon. However, in C, you get into the habit of always putting a semicolon after everything. But you got to remember that if you define some constant data, that you don't need the semicolon. This is incorrect. This will lead to a syntax error if it's used in expression like that. So if you actually try to use that define, it's going to be okay to have that semicolon at the end, but when the preprocessor runs, it's going to insert exactly what is in that define. So it's going to insert into end of data 999 : This is what the compiler is going to see it, and it's going to actually cause an error. That would be a syntax error. Omitting a closing parentheses or closing quotation marks on any statement. Very common. This is also directly related to brackets too. Having a starting curly brace and then not ending the curly brace. Same thing with parentheses. In this case, we have 2 starting left parentheses, or 3, but we only have 2 ending parentheses. We're missing an ending right parentheses. That would be a syntax error that the compiler would find. So when you're using embedded parentheses to set apart each portion of an equation, it makes for a more readable line of code. You want to use parentheses. However, you want to make sure they all match. You start a parentheses, you have to have an ending closing parentheses. The same with curly braces. You start a curly brace, it has to have an ending curly brace. So either you have too many or you have too little, but the compiler is going to complain, and this is very, very common. So the second line here is missing a closing quotation mark as well, this print statement. We don't have an ending quote. The compiler will complain about that. Both of these will generate a compile error. Sometimes, though, the compiler error is very misleading because it doesn't actually know where the error occurs. It thinks the error might have occurred on a subsequent line. So the line that it tells you the error might be misleading. So depending on whether the compiler uses a parentheses or a quotation mark on a subsequent line, it will actually complete that expression. So it will move the error down into another line. And that's where it will complain and say that's where the error is. But the actual error is higher up above where you meant to place it. These are some common mistakes that I see a lot of C programmers making. And they're easy to fix, and if you understand them and study this, you'll know not to make them. It's okay to make them as a beginner, but as you code more and more and get more practice, you'll realize, hey, I forgot a parentheses, I forgot a bracket, I didn't use the equals and the equals correctly. I'm using pointers incorrectly. I didn't allocate any memory. All these things will come more second nature. Thank you.